Hello, and welcome to another one of my recordings. Through this recording, I'm going to cover some of the object-oriented programming concepts discovered in Chapter 8 of your book, and hoping that could answer some questions and even forces you to ask some questions. Essentially, object-oriented programming involves the use of real-life objects in programming exercises or programming projects. And the thing that you really have to kind of look back is when you look around, I guess, in the real world, the world is made up of objects, and objects have attributes, things that define them, and they also have characteristics, things that they actually do. So, we also call attributes properties or state of an object. Property will be a part of that, and then the behavior of the object is what it does. So up to now, we've studied variables, which are used essentially to define the attributes or properties of an object. We've also done methods, which define the behavior of an object. So putting them together, we have the concept of object-oriented programming. So, so essentially, uh, using our knowledge up to now allows us to actually create objects and then write programs that use them. Okay, so essentially, here's an example. You have a class. Now, a class essentially is the definition of an object. So, for example, we have a class called circle. Class circle will have data fields such as radius and methods such as getting the area or calculating the area. And from the circle, we can create as many objects as we want. You'll notice I created an object 1 and I set the radius to 10. So I could call this method to get the area of object 1. I can create object 2 with a radius of 25 and do the same thing with the get the area and so on. So as you can see, you write you define the attributes and the methods of an object in a class, and then you can create as many objects as you want from these classes. Essentially, what this does, this buys you, is the ability to reuse existing code. If the definition of the method getArea ever changes, the objects don't have to change because they're only just using this method getArea. So the data fields or attributes or properties, they're all synonymous, and methods or characteristics or behaviors are also synonymous. So with this example, notice I have actually 3 distinct variables, object 1, object 2, object 3, from the circle class. Now that you already know how to use arrays, it is also possible to create an array of objects where each element of the array would be one of these objects. So I'll give you an example of that also, hopefully through this recording or other recordings. All right, so let's move on. So classes are constructs that define objects of the same type. So essentially, just the only thing you really have to remember is that the class or a Java class is essentially the definition of an object you're trying to construct. So here's an example, the class circle, double radius equals to 1. That's the data field. Now this syntax you've already seen. This defines radius to be a double, and you're setting it equal to 1. A constructor, if you, well, actually, you don't remember this, but a constructor essentially is a method that has the same name as the class. And because this method is always associated with a pair of parentheses. Now you'll notice that this constructor doesn't have anything inside the parentheses. This is a no argument constructor, sometimes also referred to as a default constructor, but we usually call it just a no arg constructor. And notice I can also create another method named circle. Again, the name of the method and the name of the class are the same. That's what constructors are. And notice this constructor accepts a parameter, in this case, new radius. Of course, this could be anything you like, and you always need data type. Now, you've seen this before with all of our coverage of methods in earlier chapters. Hopefully you remember that this concept of having two methods or more than one method with the same name is referred to as overloading. So we can actually overload our constructors. Notice this constructor or this method, all it does is sets the radius equal to whatever is passed to it. And then double get area, essentially get area is a method. Notice it doesn't take any arguments because to find the area, all you need is the radius. And the radius is a part of this class circle. So notice that you don't have to redefine radius in here because radius is actually global to this class definition. So what do we have here? We have a class circle. We have a data field. Radius. By the way, notice that this doesn't have an access modifier. By default, Java variables and methods, if you don't provide the access specifier is going to be public, meaning that they're available to objects outside of this class, which is not a good idea. You'll see that by default or by convention, we're going to make these private. But the methods, though, we want them to be accessible by all objects of this type. So that's why we always use them as public methods. Okay. So and by the way, this is so if you look at your assignment, you may notice the word utility class. This is what we mean by the utility class. The utility class is the class that defines an object, or essentially provides the definitions. A UML, or Unified Modeling Language, is essentially nothing but a way to diagram or flowchart the definition of your classes. It's really important on the highest level of things, and I believe one of your homework assignments have asked you to turn in a UML diagram. So a UML diagram always looks like a little table with one column. The first row is going to be the name of the class. The second would be a list of all of your data fields or attributes. We also specify, so we specify the name and the data type. And then the constructors and the methods. Notice the UML diagram doesn't give you any detailed information. It's usually referred to as an interface to the class. The implementation is the actual code that performs actions. These are just interfaces to the various constructors and the methods that this class has. And then when we say circle 1 is a circle 2 is a circle, and so on. That's how we read it. We say circle 1 is a circle. Circle 2 is a circle. And the only thing they have different is their radiuses. All right, so let's go ahead and do a couple of examples here. So, and again, these are all in your book. So I'm going to start with this file called test_simple_circle.java. I will provide this as a part of this recording. These are also available in your from the website. So hopefully you've already found these files. So yeah, public class test simple circle, and from the terminology I've been using, everything from here to here is referred to as the test class. The test class essentially is the class that contains the main method. That's the only difference. So let me just do this. So this is the test class, and this is the end of this. It's always a good idea to annotate these things. And this is the utility class. We usually have these in different files. In other words, ideally what you want to do is you want to highlight these and just delete it from here, right? So cut it from here, create a brand new file and name it simple circle. As long as they're in the same folder, Java can compile and essentially use these. So for this example, I have, they're showing you, or the book is showing you that it's possible to have both the test class and the utility class or classes in the same file, but that's not a good idea. The other thing that you'll notice right away from here is that the public class, or the class that's defined as public, must have the same name as the file. So this, if I say public class test simple circle, it better be saved as the same file name .java. So test simple circle .java. And you cannot have two public classes in one file. So you can't say public class. You'll get an error message if you do that. So just a class. Again, this is not a good idea. So the next example, I'll show you the proper way of doing this, or we could actually take this and fix it. All right, so I'm going to compile this thing. And while this thing is compiling, a couple of things to note then is that just like before, we always start with bin. Simple circle 1. You've seen statements like this. If I say double x or int y or string name, all we do is we define a variable of this type. It just so happens that simple circle is not a primitive data type. It happens to be a predefined class. So what we're saying, this is really an important statement to understand. What we're saying here is that circle1 is an object of type simple circle. We use the keyword new to actually construct or create the object. And we use the name of the class again, essentially using the constructor to create the object. So when Java sees this statement, it says I'm going to create this variable circle1, and I'm going to call a method named simple circle in a class called simple circle. So it looks, right now, it looks inside here in this file or in the same folder for the definition of the method simple circle. Well, we're lucky because it finds it right there. So we come in here and it says, here's simple circle, double radius, that's just a data type or an attribute of simple circle. Remember, what Java is looking for a method named simple circle without any parameters. So let's look for it. It's right here. Simple circle, no parameters. So we execute the method. How many lines of code is in this method? Well, just one. And it says radius equals 1. All we just did is that we're saying that the radius of circle 1 is equal to 1. So let me just write this here. So we're saying circle 1 dot, we use the dot notation just to provide membership. Radius is now 1. That's all. We set the radius of the circle to 1. We initialized, or we constructed an object named circle1 with a radius of 1. Now here's the system.out, the area of the circle of radius plus, so this you already have seen, plus circle1.radius. So he says, well, just give me the radius of circle 1. Well, what is it? It's 1. So to do that, so it's going to print 1, is circle1.getArea. Now getArea is a method that belongs to the object circle1 that is of type simple circle. So where is getArea? Well, it better be in the definition of simple circle. So let's move down. Do we have a getArea? Surely we do. And all this says, it says return back radius. Now, whose radius are we looking at? Well, because we called this with the object circle1, we're looking at the radius of object circle1, and we already know it's 1. So what Java is going to do is just going to say 1 times 1 times math.pi, which is 3.14. So it's going to give you the radius of the area, or the area of a circle with a radius of 1. All right. Now, as you notice, there's a lot. I don't really have to do any of this stuff to calculate the area of a circle, right? The formula is already there. We're adding all this extra overhead because when we start writing bigger and better programs, you'll find out that writing classes and defining objects from those classes makes your programming life a lot simpler, and it makes your programming maintenance a lot simpler. So, okay, so now that you've seen this, what does this statement do? Well, it says create an object circle 2 from simple circle. We'll call a method called simple circle that accepts a number. So sure enough, we're not going to go here because this doesn't accept a number, but this does. So it just says radius equals new radius. So remember, we passed 25, so the radius of circle 2 is 25. So this thing is going to display 25 here, and then 25 times 25 times pi would be the value here. Here's the same thing, radius 125. Same exact thing. We'll go in here again. Notice how we see this, we transfer control, we find what it's supposed to do, we keep track of this. I mean Java is actually keeping track of all these variables. And circle 2.radius is equal to 100. Well, what does this statement do? It's simply resetting the radius of circle 2 equal to 100. Now, notice here they have a comment here that says or circle 2.setRadius 100. Now, for this to work, I have to have a method called setRadius. Do I have one? Oh, sure enough, I do. Again, our task is really to define all of these. But that's what they're showing you, that this is another way of doing it. Actually, this is the better way of doing this. Again, pretty soon you're going to see that the moment I make this private double radius, this code here is going to fail. When I actually try to set the radius like this, because I can't access a private attribute, this will fail. I'll show you how that works. Okay, so let's just quickly compile this and let's run it. And as expected, it says the area of the circle of the radius 1, 25, 125, and 100, right? So this works the way it's supposed to. Now here's what I was going to do. I'm just going to do what we're supposed to do, which makes this a private. Again, by convention, this must be private. All right? Now I'm going to compile this, and how many errors are we getting? We're getting 5 errors. And notice right here, it says radius has private access in simple circle, meaning that you cannot directly access circle1.radius here. So all of this code is going to fail because we're using it here and here and here. All right, but we do have a method called setRadius. So can I use this? So, oh, well, actually, let's see if we have a method that gives me the radius. Do I have a getRadius? So look in here, I don't see one, but I can easily write one, right? So I could go in here and say public, because remember it has to be public. Yeah, remember the default is public, so that's why they don't put it there. Public, double, getRadius. No parameters, because all it's going to do is going to return the radius. So we do that, and we do that. There you go. So I just added getRadius. Now, right here, instead of saying circle1.radius, I have to change it to, let me just cheat here. So instead of directly accessing it, I'm just going to say, do this. Just like this getArea. So to fix this, I'm going to do that. Again, don't forget the parentheses after the parameters, or after the function name or the method name. And let's see. Oh, and this one, obviously, I can't do it. But look, I've got an example right there. So why not comment this line and just say circle.setRadius 100. I believe I'm not accessing. Oh, I'm doing it right here. So I need my getRadius here. All right, let's compile this and see if it compiles. Ooh, it doesn't compile. One error right here on circle 3 get radius. I forgot parentheses. And then since I'm here, well, that's just one error, so I think that was it. So again, remember, you have to be consistent. Now, if I run this code, should I get the exact same answer as before? And the answer is yeah, because it's the same program. So that's it. All right, now, remember I said that we shouldn't be defining this in here. I'm just going to grab all of these, right? All of that. I'm going to cut it. I'm going to go in here and do a new file and paste it. Now remember, I have to make this. I'm going to make this public class simple circle. Well, I'm going to copy that. I want to save this as, remember, it has to be in the same folder as the test class. So I'm just going to do that, .java, and save. There you go. And there you go. So I'm here. Remember, I deleted all of that. So you have the test class in one file and the utility class in a file of its own. So compile and run, and we get the same thing. Now remember, I can only run this file, the one that has the main method. I cannot run a class definition because it doesn't have the main and it's not doing anything anyways. Okay, so that's an example. Let's see, there was another example. I'm going to go ahead and close these, not to confuse you. I'm going to go in here to, there's a, let's see, there are two files, testtv and tv.java. Again, these are all from your textbook. Notice how they have the testtv.java is the one that contains the main method. tv.java is the one that contains the definition of the utility class. All right, so let's take a look at the definition for public class TV. Just look at this. How many attributes does this class have? And if you do this correctly, if you write all your definitions for attributes at the beginning, whether you don't have to, but it's always a good idea to do because I could quickly see that I have 3 attributes: channel, volume level, and on. All right. Now, if you remember from maybe 5 minutes ago, the default here is public, but by convention, they should really be private, and then we create public methods to have access, to give these access. Again, I'm hoping that you read your book and ask a lot of questions when you start reading your book. So let's test your understanding. What is this? Well, it's got the same name as the class, so this must be a constructor. How many parameters does it have? None. So this is called the no-arg or no-argument constructor. What does it do? Really nothing. And it's fine. You can have methods that don't do anything because you can then go and add code to it later. How many constructors do I have? Well, let's look at that. There's one method with the name TV, and there's nothing else. So just one constructor. All right. I have a method called turn on. And what does it do? It makes the attribute on equal to true. Turn off makes the attribute on equals to false. Set channel. It accepts a number, and then it sets it accordingly. Okay, so I'm going to leave this as an exercise to you because all you're doing is you're changing these variables, volume levels, and channels. And again, this definition is comes from the requirements of the class that you're trying to write. And then testtv simply writes the main to actually exercise or use your utility class. So TV1 new TV. What does this statement do? It creates an object named TV1 from the TV class using this new operator, calling a method named TV without parameters. And that means right there. So it's going to go here. And of course, it's not doing anything, so it comes back. So we just constructed an object with nothing in it, or no attributes associated with it. Now, TV1.turn-on. What does this do? Go and find the turn on, and all turn on makes on equals to true. So if you're keeping track right now, maybe on a piece of paper, your variable TV1 right here, TV1's, what was the name of the attribute? On attribute is now equal to, is now 1, is now on. Okay, and that's all we're saying. We're saying keep track of these things. TV1.set channel to 30. Well, let's see what this does. TV1's set channel. Okay, where's set channel? Right here. Looks like it's setting channel, so that's what it's doing, right? TV1's channel is set to. Remember, we're passing 30, so let's see what does it do with 30. So it comes out here, it says, is it on? Well, remember, on is true, because I already set it to true. And is 30 bigger than 1 and less than 120? The answer is yes. So channel, in this case, TV1's channel becomes new channel, which is 30. So it's set to 30. Okay, set volume works the same way. TV2, same thing. And then, as you might expect, these print statements are going to actually display or access the attributes of your class, or in this case, your objects. So if I compile this code and run it, this is what we get. TV1's channel is 30 and volume is 3. Okay, we didn't go that far, but hopefully you can verify that for yourself. Now again, remember, if I go in here and change these to private, none of this program will not compile. So notice if I go, I just made a change here, right? Private in channel 1. I go here and I compile. And it says successful, because notice this one hasn't been compiled. So I'm going to compile this one. Now I go back and say, okay, compile this one. Now this is where I get my error, right? Because TV1.channel, he says, is a private access in TV. So given what you just saw, can you imagine what we need to do? We need to go to tv.java and write a method called getChannel. And obviously, for every one of these attributes, because they're private, we usually have a get method that returns its value, and we have a set method that sets its value. So usually what you're going to see is that these are all private, and you almost always are going to have get and set methods in addition to other methods like channel up or whatever else you want to do, depending on what it is you're doing. Okay, so that's that. And one more example I want to give you, so I'm going to close these two. And the other thing is this, the fact that we could create an array of objects. And your book has a program called Circle with Private Data Fields.java. I'm just going to open it up, and we're just going to look at this. So here's Circle with Private Data Fields. Okay, it doesn't have to be that long of a name, but they're just trying to show you how these things work. So what is this? Is this the test class or the utility class? And the answer is, it is the utility class, because it's defining the class. There is no main method. Okay, so that's that. So I can compile this, and it should just compile fine. And let's just look at this. It's got a private double radius equal to 1. So, and it's got a private static int number of objects equal to 0. So how many attributes does it have? 2. Radius and number of objects. Notice that number of objects is a static, radius is not. The word static essentially means that we only have one copy of that variable, which essentially makes it nice, because every time now you create an object, this variable number of objects retains its value. It essentially retains its previous value. So do we have a constructor? Yeah, public circle data fields, same thing. It's a no-R constructor, and all it does, it increments number of objects equal to 1. So it looks like anytime I create an object, I'm going to go here. So what am I actually calculating or keeping track of? The number of objects that I create. Here's a circle with private data fields with a parameter. Okay, same thing. I want to increment this because I want to keep track of that. So you have the gets and you have the sets, and actually I need to go here and find the main, let's see, uh, the class that contains, is that the total area maybe? When you go in here, yeah, the total area is the one that actually creates. Now notice right away, you've seen this before, right? I mean, you've seen something like this, double scores, um, like this. This this defines um, this defines an array, spell it right, an array named scores that could hold an array of doubles. Well, this says create an array called circle array of this type. And then here we say circle array equals, I'm going to get rid of that. And this one says circle array equals create circle array. So when you see something like this, you have to ask yourself, well, where is create circle array defined? Well, create circle array is right there, right? Public static. That's actually the name of the method, um, and the data type is going to be the name of the class, bracket bracket. Again, remember bracket bracket says it is an array, and this is where we're creating the object. We're creating new circle fields. Remember in our previous examples, this would have been new double 5. Now we're saying new circle with private data fields 5. I want you to go through this. I'm actually coming to the end of the usual 30-minute slides. And again, if you guys, if you all want me to do more of these, all you have to do is post a question or ask for some specific demos of specific maybe slides that you see in your chapter, or examples that you see in the chapter. So feel free to ask, and I should be able to provide more recordings, more specific recordings. Okay, so I'm just going to run this thing and compile it, and of course it's going to compile, and so I can run this thing, and this is what it's doing. By the way, right before we go, I want to go in here. This is my main method. Remember, we have a variable called number of objects, right? Number of objects. And I have a method named getNumberOfObjects. So can I actually find out how many objects I created? So I can say system.out.println. We created how many objects? Whoops. Get number of objects is right here. I thought I copied this. Control C. No, this is a static, so I don't need an object to use it with. So I have to actually use the class name, which is, I guess I can just copy it from any one of these. Remember, I can only do this with static member variables or static attributes. So I say, give me the number of objects for this class. And it was a method, so I need parentheses, plus objects so far. I say so far because we could be doing a lot more of these with the remaining lines of code, or with more lines of code. So let's see if this thing compiles, and let's run it. And now it says we created 5 objects. Okay, and is that true? Did we create 5 objects? Yep, surely we did, right? Now I'm just going to quickly make this change. Instead of 5, I'm going to make this 7 and see if it compiles. Looks like it compiles. And run. And how many objects did I create? 7, because I created an array with 7 objects, or 7 elements. Let me put this back. Okay, we'll save this, and I'm done. Hope this was helpful. Have a good day or good night.